4,200 carats. It is 840 grams. And this is wood opal. This is a piece of petrified wood. Was a root going through the ground. Sat in the ground, I think probably, let's see, sat side up, like this. Okay, so look at the colors up there. Man. So the upside is what we see here, and when the opalization happens, the spheres of silica arrange themselves according to their orientation to the earth. They are upside, and on the bottom they won't look so good. But here the bottom is still clay. You can see there's opal showing, color showing. The whole thing is opal, right? This is a piece of petrified wood that was replaced by kaolinite clay. That's how it all works. Even the stuff that's not opal, it turned into a cast of kaolinite clay from volcanic ash. The water transported the volcanic ash particles, and when they're in that water, they are chemically weathered and mechanically weathered by banging into things and stuff as they move through the clay, and they turn into kaolinite clay from volcanic ash, and it's got two layers. One layer of aluminum oxide and one layer of silicon dioxide. Opal is silicon dioxide. During opalization, the aluminum oxide layer is stripped away, and it leaves that layer of silicon dioxide, and that rolls up into a little sphere. It collapses into itself because it's being attracted by iron oxide or iron sulfide in the sulfide solutions that precipitate opal and also deposit things like gold, silver. They are responsible for, sulfide solutions are responsible for secondary mineralization. So they exist everywhere. It is part of water passing over molten rock, passing out of molten rock, and carrying those minerals with it, and it becomes acidic. And we call it sulfide solutions. That's what makes things tick down there. And so the sulfide solutions precipitate opal. So this was a tree root, sat in the ground, tree died, and this root rotted away. There's no root left. This is a piece of rock, solid rock. what you see here came about because that volcanic ash turned into clay, and the sulfide solutions in Banten, Indonesia, surrounded this root, and it opalized. I don't know what the black spots are. I don't know how they form or anything. I know that they are part of the structure of the stone, and I can show you that in some other pieces. But they form this patchwork polka dot harlequin, or polka dot patchwork harlequin, and only in Banten wood opal from Indonesia. Banten is the westernmost province on the island of Java, and all the volcanic ash blows down, and that's what this is. So what we're seeing here now, my experience with these stones is that I could clean this off down here, and it'll just look like a stick, like a root. But there's a lot of these color layers showing throughout the stone, and even the black part itself is showing color. So this is not just 4,200 carats with it just on the top. I think it's all the way through this stone. So you can see it's tremendous stone, and it opalized all the way through. And I'm gonna clean this off slowly, and we'll see what's underneath. See, the clay itself down there is black from the sulfides, and it is iron sulfide that makes black opal black, which is why Banten, Indonesia has the finest black opal in the world. Peace.